In these notes, we are going to be reviewing elimination. Elimination is another way of solving systems of equations. That you learned in 9th grade. So the first step is to arrange the equations so that like terms, remember like terms have the same variable with exponent, are in the same columns. Remember columns go up and down. Luckily for us in the first example, x is on top of x, y is on top of y, the equal signs are also on top, and the numbers are on top of each other, so we get to skip this step. The second thing we're going to do is look for inverse or opposite coefficients. Coefficients are the numbers in front of variables that will eliminate one variable when combined. So we look over at this example. We see that positive 1y and negative 1y have the opposite coefficients. One is positive, one is negative. Therefore, if I were to add these, 1 take away 1 or y take away y will eliminate and become 0. So this is another way of canceling out. Now I get to add everything in my equation. 3x plus 5x becomes 8x. I drop down my equal sign and I add 6 and 10 to get 16. My second step is to divide by 8, and I've now successfully isolated my x variable. However, we're not done. We want to solve for the y as well. So I'm going to plug 2 into one of my equations. It doesn't matter which one, you'll have the same exact answer. I'm going to choose the first equation. So 3x plus y equals 6. I'm going to plug the 2 in here. When I subtract, everything cancels out, leaving me with y equals 0. So my final answer is 2, 0. Remember, x comes first and then y. In our second example, we're going to be doing the same thing but with an extra step. So again, everything's lined up perfectly. But there aren't any opposite coefficients. Positive 1, negative 2, positive 2, negative 3. Nothing is canceling out right now like it did before in our top example. So we're going to go to step 3. If a pair of inverse coefficients cannot be found, create a pair using multiplication. Or in other words, distribution. So I notice that my x's have the same coefficient. That's really nice because that means only one of them needs to change. They're both positive, so I just need to make one of them negative. And it doesn't matter which one. I'm going to choose to make the top one negative. To do that, I have to multiply by a negative 1 throughout the entire equation. I can't just multiply the first thing. It has to distribute everything. So this becomes a negative 1x, negative 2y, and negative 4. So I've created a new equation using distribution. Now my coefficients do cancel out. 1 take away 1 or x take away x is 0. Negative 3 take away 2 is negative 5y. 5 take away 4 is 1. I'm going to divide by negative 5, leaving me with y equals negative 1/5. Step 4, substitute the value found in step 4 into either of the original equations. This is super important. When you substitute negative 1/5 back in, you cannot use the equation that you made. You have to use one of the original equations. I'm going to choose to use the first one. So we have x plus 2y equals 4. So that's the original equation. I'm going to plug this y into my equation. We then get x plus 2 times negative 1/5. This becomes negative 2/5. I add my fraction to both sides, those cancel, and therefore x becomes 4 over 1 plus 2 over 5. We don't have the same denominator right now, so I'm going to create it by multiplying this by 5. Now I have 20 over 5 plus 2 over 5, which gives me 22 over 5. So my final answer is going to be 22 over 5, comma, negative 1/5. And that means that these two lines intersect on a graph at 22 and negative 1/5. Now let's make sure that this works by using